Hello, this is 14.7 working with natural logs. This is again Year 1 Core Maths. So this is now all about the natural log. So what you need to remember, just in case you've forgotten, is that E was rather special, and it came about because when you differentiate e to the x, you get e to the x, and e actually has a value, 2.7 and so on, and it is quite a special value. And when we're talking about natural logarithms, the base for our natural logarithm would be e, so this 2.7 and so on, which you can get up on your calculator, remember. So looking at example 17, and the first one here that we're going to look at, when I rewrite this, this is our base, and this here is the exponent, this is our exponent, obviously, here. And we've got to think about how we would write this in a logarithmic form. So to remind you, it's log base e of 5 equals x, or how we'd usually write it is x equals log of 5 to the base e. Now, this bit here isn't actually needed. That's me just explaining it. It's explaining that now this is going to be base e, okay? And this 5 here, that is all the things we've done before if you go back to previous questions. Now, we don't write this. We have a shorthand on our calculator for this, and it's actually x equals the natural log, which is ln, of 5. So the bit in the middle is the maths behind it, but actually all that is expected is that you can write that and realise that to find x, the inverse function is taking logs, and it's the natural log of 5. So x would equal the natural log of 5. Okay? So coming over to this one here, so let's just underline that, so that's your answer. This here actually means log to the of x to base e equals 3. That's what that actually means. And if you remember, that means that e to the power 3, because remember 3 is your exponent, equals x. And again, we don't need to write this. You are expected to realise that the inverse function would be x equals e to the power 3. So the bit to clearly understand is how to go from here to here. The bit in the pink box is the y. And really to understand that if e to the x is 5, then x is the natural log of 5. And that if the natural log of x is 3, then x is equal to e to the power 3. And this again, it's not going to be a question. I feel I say this often. It's not going to be a question at A-level maths, but it would be that last stage. So in a question, you may find the last stage of your question, you end up with this, and they're asking you to find what x is. And equally, you may get this as the last but one stage of your question, and you're asked what x is. So you do this. So you may have differentiated a function, many different things you could have done. And from here, you're going to have to get to these answers. So that's example 17. Let's move on to example 18a. So using our knowledge from the last set of examples, I know I can write this as 2x add 3 equals the natural log of 7. Okay, because if I have e to the 2x add 3, then 2x plus 3 must equal the natural log of 7. Therefore, keeping on with my solving now, it's the natural log of 7 subtract 3. And so x would equal the natural log of 7 subtract 3, and that answer all divided by 2. That would be an exact form. I equally could write it as an exact form like this. Both would have to be acceptable unless they requested a particular form. So either of these solutions is absolutely fine. So make sure you understand that, and then we can move on to B. So moving on to B now. This one here, well, first of all, and it is about unpicking a function, you need to really realise what this is actually saying. And it might be a bit unclear because it's just the x that is being logged here. So the next stage is 2 natural log of x equals 4, because I subtracted the 1, because this would be a little bit like this. You would subtract the 1 first. So this is going back to pre-GCSE. You take that 1 off first. What's the next thing you'd do? You'd divide by 2. And then what would you do? Well, the inverse function of the natural log of x, that's equal to e to the 2. And they don't want any more because they've actually asked for the exact form. If they hadn't asked for the exact form, then what you would need to do here is then type it into your calculator. So that's B done. Let's look at C. So here's C. Now C is an interesting one, and I'm really glad that it's actually come up here. C is the question that when I see it, people get stuck on it because they don't see what it is. And I've mentioned this before about seeing clearly what a question is. This is a quadratic. You may not have noticed it, but it is. So here, first of all, what you need to realise is we've actually got that plus that, take away that. And spotting that is the thing that holds people up. Might be one of those things to write down somewhere just so you can look that back up before going into an exam. Because you may find that you forget that because you won't come up with one of those questions before you walk into an exam. So it's perhaps something to put on the set of revision notes that you'd look at just before you walk in, because that's what catches people out. And then it's according to how you want to go from here. Some people like writing let y, let's actually erase that to make it slightly neater, let y equal e to the x. And then you could write y squared, add 5y, subtract 14 equals 0. And we then need to go about factorising that. So if you've got one of those clever graphical calculators now, you're typing it in. And you'd get that. And remember, that means that it's e to the x, add 7, and e to the x subtract 2. So I have from this that e to the x equals negative 7 and e to the x equals 2. Now remember, here I'm going to do this one first. Here x is equal to the natural log of 2. Now this one here, the natural log of a negative number isn't possible, and yes, the examiner will check you on that. They'll see whether you can deal with this, and what you need to just write is no solution. That's what they're looking for. Do you realise there's no solution, that you can't do the natural log of a negative number? And just to remind you, I have done this previously on other slides. This is your log graph. That's 1. What do you notice about x, negative x values? It's not possible because there's an asymptote and it is here. So that curve does not cross the y-axis. There are no values of negative x. So that one very commonly comes up and tricks students, but it won't trick you. So now, time for practice.